We're now ready to construct a cumulative distribution. Remember, as we were talking about probability distributions, we have a probability mass function, which would be our probability distribution. But then we also have a cumulative distribution function as well. So it's very similar to what we did before. Recall we went on, we're going to go to the cell that we desire. I'm going to click on the function, make sure it's on statistical, and I'm going to go down to binomial distribution. And so we're pretty much going to go through the same steps that we went through before. The number of successes, I'm going to go back to, we're starting with 0. As I try to copy those values, I don't want the A to change, so I'm going to put a $ in front of the A to show that I don't want it to change. The number of trials, there are 20 questions, so I'm going to put 20. Actually, let's not do that. Let's go on and get 20. I don't want that to ever change either, so I'm going to put a $ in front of the E, and I'm going to put a $ in front of the 2. The probability of successes is 0.2. I can get that in the F2 cell. I don't want that to ever change, so I'm going to put a $ in front of the F so that the column doesn't change. And then I'm going to put a $ in front of the 2 so that the row doesn't change as well. So all of this was the same when we were generating the binomial distribution. What changes for the cumulative distribution is, instead of putting false, I'm going to put true, because we do want a cumulative distribution. Click on OK, and that gives us the first cumulative distribution value. Now recall that the cumulative distribution value will give you the probability that the random variable is less than a particular value. So it's always, for the first value in our distribution, it's always going to be the same as the probability of getting that first value, which in our case is 0. But if I let the plus sign come right there in the corner and I drag everything down all the way down to 20, you will see that the probabilities change. And you will see that in the cumulative distribution, if I click right here in the row where x is equal to 1, that would be the probability that the random variable is 1. In our problem, that would be the probability that the student gets one answer correct. Okay, well, we know that that probability is 0.057646. If I skip down here to this value here, the probability that the student will get 6 or less correct answers is going to be 0.9133075. So in our problem, number 5 asks, what is the probability that less than 7 questions are correct? Here's the value of the cumulative distribution function when x is equal to 7. Since we don't want to include the 7, because it says what is the probability that less than 7 questions are correct, we want to choose the probability that x is less than or equal to 6. And that would be the probability that x is equal to 6, or 5, or 4, or 3, or 2, or 1, or 0. So you can add all of those up. But the quickest way would be to look at the cumulative distribution where x is equal to 6, and you will get 0.913 as the probability. So the answer to number 5 will be 0.913. The last question, question number 6, asks, what is the probability that between 5 and 12 questions are correct? Well, recall when we used the cumulative distribution function to evaluate this, we would evaluate the cumulative distribution function at the largest value, in this case, which would be 12, minus the cumulative distribution function value at 5. So I'm going to just put that in the cell right here so that we can figure it out. So I'm going to put my equal sign in the cell to show that I'm going to be typing a formula. And it's going to be 12. The cumulative distribution function evaluated at 12 minus the cumulative distribution function evaluated at 5, which is in C7, and I get the value of 0.19577. So this is equal to the probability that the random variable is between 5 and 12.